Hi everyone, my name is Tina. I'm a PhD student at Monash University in the Department of Econometrics and Business Statistics, and I'm also a member of Monash Numbats team. Well, today I'd like to tell you about the spinebil package, which is used for investigating new projection pursuit index functions. I'm working on this as a part of Google Summer of Code project. The spinebil package was originally developed to evaluate projection pursuit index performance using tour methods. However, it was removed from CRAN back in June 2020, mainly because a dependency package was deprecated and there were additional CRAN requirements that needed to be addressed. Well, projection pursuit relies on optimizing an index function to find interesting low-dimensional projections of high-dimensional data. The idea is that the index should highlight meaningful structures instead of random or normal patterns. It's a bit like this shadow sculpture analogy which you see on this slide. From most angles, it just looks like a mess. But from one carefully chosen projection or angle, suddenly a clear shape, like a human shadow, which you see, is revealed. Well, on this slide, in the right plot, you can see examples of pipe, sine, and spiral structures, each shown in both nuisance or noise and structured forms. And in the left plot, you can see how the projection pursuit index values for different indices evolve over a sequence of projections. But the challenge here is that it's often hard to tell if the optimization is struggling or if the index itself just doesn't detect the expected structure. Now, in this project, I would like to use scagnostics, which is short for scatterplot diagnostics, which convert the shape of a scatterplot into numeric measures. Scagnostic measures such as stringy, skinny, and clumpy are just some examples of scagnostics, but there are other scagnostic indices as well, which each of them capture different structural patterns. However, turning these indices, scagnostic indices, into projection pursuit indices is very tricky. They can show inconsistent behavior under noise, making them very hard to use reliably for projection pursuit for high-dimensional data. As part of this project, I would also like to compare the scale for different indices and see if they consistently fall in the 0 to 1 range, since both scagnostics and other projection pursuit indices are typically scaled to that interval of 0 to 1. And I plan to compare them under different data conditions and different structural patterns to better understand how stable and interpretable these measures are. Well, to wrap up, overall, the goals of this project are to get spinebil back to CRAN, enhance the package's diagnostics for projection pursuit, turn scagnostic into projection pursuit indices, and assess and validate these indices using a spinebil package. And I also plan to expand the diagnostic functions to explore the effect of scale, distribution, and sample size so we can better understand how these indices behave under different data conditions. Well, if you'd like to check out this spinebil package, it's available on GitHub repository below in this link. And thank you so much for listening.